Hello there, we're going to take a look at an amines question. Usual format applies. Black text is the question, red text additional information and ideas, blue text is the answer. Pen and paper at the ready. Don't think you're going to need a calculator for this one. Let's take a look at the question. So before we start, related topics, obviously amines and haloalkanes. Need to know about reaction mechanisms and, as always, reagents and conditions. So here is the first part of the question. Take a look, pause the video, press play when you are ready. So welcome back. Balanced equation, and we've got the reagent of ammonia and it's in excess. So the excess is important. This means that we will make the primary amine. If we don't have an excess of ammonia, it could make the secondary or tertiary amines, because the amine that's created can also react with the haloalkane. So we need to balance this with 4 molecules of ammonia on the left hand side, and then the ammonia would react to make the ammonium bromide salt with any HBr that is formed. So we get the primary amine. So 1 mark there for the organic product, 1 mark for it being balanced. Okay, so take a look at the next part of the question. Pause, press play when you're ready. Welcome back. So we're going to have a mechanism, and it's given us the mechanism in skeletal formulae. So you're going to need to know curly arrow notation. Curly arrow represents the movement of a pair of electrons. It's always associated with bonds breaking or bonds forming. So we've got a little bit more space now. So in the first step, I think it's a good idea to put the lone pair of electrons on the nitrogen of ammonia, because this is going to be used to form a bond with the carbon, the same carbon on which the CBr bond is breaking. So the black arrow given to us in the question represents a bond from carbon to bromine breaking, and the arrow in blue there that I've put on going from the lone pair of electrons on the nitrogen shows a bond forming to that same carbon with the NH3 molecule. That gives us the intermediate product. So the nitrogen now has got a positive charge because the nitrogen is making 4 bonds. That bond from nitrogen to hydrogen there, the curly arrow represents the pair of electrons is going to the nitrogen, so that will neutralize the nitrogen atom, and the H will be lost. So the next stage will be going to the final product. Now you might ask, well, where's the Br minus gone to? It's quite acceptable to put the Br minus as an intermediate or at the end. It will be there, so Br minus will also be formed, and that will maybe react with any H pluses. And if it was in excess of NH3, any HBr form would react with the NH3s to make the NH4Br salts. There's the H pluses. Okay, take a look at the question, have a go, and press play when you're ready. Welcome back. So these reactions can cause or can lead to a mixture of different products, because the amine which is produced can also react in place of the ammonia. A secondary amine could be formed. In this case, we have a special case, because the amine, one end of the molecule that's formed, could actually react with the bromine at the other end of the molecule. It's a nucleophilic substitution reaction, and so either the 2 ends of the molecule can react with each other, or we could get 2 of the NH2Br molecules, so the bromoamine molecules, if you will, could react together to make a cyclic molecule such as that. Okay. Next part of the question, take a look, pause the video, press play when you're ready for the answer. Welcome back. So there's a big clue here in the question. We're going from a butane to a hexane. So the only way we can lengthen the carbon chain is with the CN- attack. So the reagent would be KCN, NaCN would do as well, KCN. It has to be an alcohol or state ethanol. The reason for that is if you do it with water, this can hydrolyze the haloalkane to make to make impurities that can make the alcohol itself. So if we actually do it in alcohol, it will prevent that from happening. So now we've made the nitrile, we can then reduce the CNs at both ends by using a nickel catalyst in the presence of hydrogen. You're not asked for balance equations, but I put the balance equations in there to in case you were asked for them. It's worthwhile knowing them. So the CN- in the first reaction is this is also a substitution, a nucleophilic substitution reaction. Worthwhile knowing the mechanism. The second stage, we've got the hydrogen from in square brackets. It's a nice way of balancing that. Just representing any hydrogen which is required for reduction there. Take a look at the question, pause the video, press play when you're ready. Welcome back. Nice little 2-marker, just a knowledge-based question. You need to know what a base is. There's a couple of different definitions. Here I've given the definition that a base is a proton acceptor. So free aminopentane is better able to donate a lone pair of electrons on the N atom to a H+ ion. So it makes it better able to accept that H+ ion. We can discuss that, or we must state that the alkyl group in free aminopentane is electron pushing. So just to represent that, I've got the two molecules here of ammonia and free aminopentane, and those dots represent those lone pairs of electrons. So in the case of free aminopentane, you can see the lone pair of electrons is further from the nitrogen, so the alkyl group is electron pushing, and so those electrons are now better able to bond with a H+ ion or to be donated to a H+ ion. Final part of this question, read it, pause it, have a go, press play when you're ready. Welcome back. I drew this molecule out. A chiral center is a carbon atom which is attached to 4 different atoms or groups. The presence of a chiral center leads to a special type of stereoisomerism known as optical isomerism. We simply need to justify that there are no chiral centers here. So no chiral center because no carbon atom present that is attached to 4 different atoms or groups. So there's the molecule, and it's not attached to 4 different atoms or groups. There's no carbon there. From the bottom left, CH3, CH2, then the carbon attached to the nitrogen, well, it's not 2 different atoms or groups because that carbon in the center is attached to 2 ethyl groups, and then a CH2 attached to 2 H's, a CH3 attached to 3 H's.